Hi, I'm Pavitran Jagannathan. Today I will be talking about optimization of instrument condition for analysis of mercury, arsenic, selenium, and antimony by atomic absorption spectroscopy. There are two types of AS used in this experiment, which are hydride generation for arsenic, selenium, and antimony, and cold vapor AAS for mercury. First of all, 30 ppb of the standard solution of mercury, arsenic, selenium, and antimony were used for all the optimization process. There are few parameters that optimize in this experiment. The first two are the concentration of the reducing agent and the concentration of the acid. For arsenic, selenium, and antimony, the reducing agent used was sodium borohydride with different concentration in 0.5% of sodium hydroxide solution. Meanwhile, the acid used was different concentration of hydrochloric acid. For mercury in cold vapor AAS, the reducing agent used was tin chloride with different concentration in hydrochloric acid. After each absorbance of the modification, the entire system was pumped with deionized water for 60 seconds to avoid any cross-contamination. The third and fourth parameters that optimize in this experiment is the flow rate of the sample and the flow rate of the reducing agent and acid. There are two flow rate adjustments that used in this experiment, which is one for the sample and one for the reducing agent and acid. The flow rate can be regulated by using the knob, which can be tight and can be released. The flow rate can be determined by using the volume of the reagent used in the measuring cylinder in 60 seconds. Flow rate also affected by the difference in pump tubing internal diameter for both sample and also the reducing agent and acid. The fifth parameter that can be optimized to enhance the result is the acetylene flow rate. For mercury, the temperature of the air acetylene flame can be optimized by the air acetylene flow rate by using Spectra AA software. For arsenic, selenium, and antimony, the optimum acetylene flow rate is 2.5 liter per minute. The sixth parameter that optimized is the flow rate of the argon gas. Usually, high volume of the argon gas is needed to strip the volatile hydride from the liquid to flow to the sample cell. However, too many argon gas may dilute the hydride form. Hence, the argon gas also need to be optimized by adjusting the flow on the gauge on the cylinder of the argon gas. Hence, the optimized rate for argon gas for arsenic and antimony is at 0.2 liter per minute, while for mercury and selenium, it is at 2.0 liter per minute. The seventh and last parameter that can be optimized in this experiment is the read delay time. Read delay time is to control the flushing time needed to effectively remove the metal ions in the quartz tube. Thus, this will reduce the memory effect or can be eliminated. What is memory effect? Memory effect happens when the metals could not atomize completely and left in the quartz tube that will affect the results and the reading of the spectrometer. So the optimum delay time for arsenic, selenium and antimony is 20 seconds, while for mercury it is longer, which takes 70 seconds for each absorbance. Hence, I would like to conclude that what is the advantage of making optimization that will bring a better result. Optimization of the instrument will improve the sensitivity and reliability of the results, which indirectly lower down the detection limit. Besides, it also increase the production of hydrides or vapor for AAS to be absorbed and the spectrum to be very clear, and this will improve the recovery. Lastly, it will reduce the chemical interferences from other species or reagents. Thank you for watching.